My name is Darren Yazzie, and this is my final presentation for CIT 260. First slide here, I'm going to go ahead and explain the difference between a static class variable and a non-static class variable. I'll also give examples of code showing how to reference and call a static function versus a non-static function. As you can see here, the differences with static is it's associated with the class and not the objects. It's also defined by the keyword static. You access it without creating any objects of its class. Memory is allocated at the time of loading the class and is only allocated once in the program. It's accessible with class references, shared across all instances, and accessed directly by name. The syntax for it, as you can see here, is with the arrow brackets, class name, dot, method name with the brackets as well. For non-static, it's associated with objects or instances. They're also known as instant variables. It's defined without the static keyword. It's instance specified, not shared among instances. Memory is allocated whenever an object is created and is allocated multiple times when a new object is created. You can access with object references. The variable must be assigned when value is defined, and it cannot be instantiated. And the syntax for that, of course, is the brackets, arrow brackets, object reference, dot, method name with the brackets. Now here is the example from our game regards to static methods. If you see the first red arrow here, private static random, and here's the variable. You got protected static void, and then here you have the static method, which in turn goes to game control, get random number. Now, when to use the static method? When you have code that can be shared across all instances of the same class, and you put that portion of code into static method. They are basically used to access static fields of the class. Now here's another example of a static variable method. In this case, as you can see here, city of Arion dot get current game. Just another example of the static. Now here's an example of our instance variables. As you can see, private player, private map, private int current population, private int acres owned. They don't have the keyword static in there. Now instance methods belong to the object of the class, not to the class, and they can be called after creating the object of the class. And every individual object created from the class has its own copy of the instance as well. Instance methods can access the instance methods and instance variables directly. They can also access static variables and static methods directly. Now the next section is arrays, arrays lists, and enums. Under arrays, they are fixed length lists, and they must have the same data type. The items cannot be changed. The items are object or primitive values, and they're referenced by index. Under array lists, they're also fixed length lists. Same data types. Items cannot be changed because they have a constant value, and they are object or primitive value as well, and they're referenced by index. Under enums, the variable length lists, they're dynamic, can be different data types. They can be changed, and in order to use object, you have to convert from primitive to object, and they're referenced by index. When to use an array list, or enums. For arrays, you use it when the list is a fixed length and all the data types are the same. Under array lists, you need to use it when you need to add or remove different data types. And under enums, when the list length is fixed, constant, and when you have the same data type is when they can be used. This slide shows an example of an array which was created. The array is fixed, as you can see here with inside the red box, and the rows and columns are of the same data type. Now here's an example of an array list that I created on an individual assignment, which was separate from the City of Arion game. Under this, I was to have a user input a range of numbers. the number would be scattered and sorted, and it would display the highest number. And this array list function here uh, basically does that, as you can see. Since the numbers change all the time and they're different, that's when this array list is used. Here's the example of our enums. As you can see, it wasn't quite finished under our game, but underneath I show an example of the animal. And tiger, king of the jungles are just data types of the animal there. And in the enum, of course, it's a fixed, the items are fixed length, they're constant, and they all share the same data type. Here's the example of for statement that I created in an individual assignment. In this case, the user would input a set of numbers, and then my code would sort through the lists and find the highest value. Now, I started out again with the array list. If you can see that in the green box right here, you got my array list. Since it's numbers, you use double, and then its name is numbers. And then it lists the new array list, which is where the input would be stored. I've got a system out print line, 2 of them, which asks the user for how many numbers they're going to input. And then the second line is the actual numbers they want in there. So what my first for statement does is it obtains the input from the user. As you see the arrow there. And pretty much it just adds the number there. As you see under the numbers add, it goes in and adds it into my array list. Double I, of course, for loops and array list starts at 0. I equals 0. I is less than a num. That gets inputted when on the first question that is entered, enter size of your array list. So anything, it stops as soon as it gets that input, and then just increments from there. Adds the number into the array list, and that's in the red box there. After that's completed, it jumps down to the for if loop. And what that for if loop does, it goes into the array list. Again, if you look at it, for int equals 0, always initiated as 0, and then the number size, usually in just array, if it's not an array, then it's length, and then in increments too. So what it does is obtains the numbers inputted in the array list, and it goes through it, pretty much searches for the highest value, and it returns the highest value number there. So we have the throw and catch statements here. This code was written for our game, and I retrieved it from the load game from file method. In here you have throw, try, and catch. Usually the try statement lets you test a block of code for errors, which is right here in the middle. And then the catch statement lets you handle the error. And the throw statement lets you create custom errors to be displayed. Now, if the value is wrong, an exception is thrown. The throw statement throws an error. The throw statement allows you to create a custom error. In this case, it will be displayed enter a valid path file in the green box. When an error occurs, usually it will generate the error and it will terminate the process. Exceptions are usually thrown when an unwanted or unexpected event occurs during the execution of the program. In propagation, when it occurs when an exception happens. Propagation is a process in which the exception is being dropped from the top to the bottom of the stack. If not caught at first, the exception again drops down to the previous method, and so on until it gets caught or until it reaches the very bottom of the call stack. This is called exception propagation, and this happens in case of unchecked exceptions. Now in this case I used the storehouse reports menu view and call the storehouse control exception, and it pretty much finds errors and just goes back and forth again, like stated, from top to bottom until it finds the error or finds a resolution to it. As instructed, here I will just explain why a character stream class should be used versus a bitstream class to read and write data to a file. If you're writing data to a file, and depending what you're doing, these are the differences in which ones to use. Under character, they read character by character. They use the Unicode encoding scheme, and they're used for input output of 16-bit bytes, and they're called by using reader and writer. For the byte, they're done pretty much byte by byte. They do not use any encoding scheme, and they're used for input and output of 18-bit bytes. They come from the file input stream and file output stream classes as well. You should not use bitstream to read character streams, and bitstream should only be used for the most primitive I/O out there. Here we demonstrate how character data can be written to an external file. Now, in our code, we use the character stream output to output the data, and that can be verified by the print writer provision report here. Also, in our main city of Aaron file, we created an output file, an in file, and a log file. Now that'll be used to basically create our output, which in this case is the log file text. Inside this try statement here in the orange bars, we open character stream files for input and output for the end user, and we save the data here as log file text. So here is our game as far as we've gone, and I'm going to go ahead and run you through what options are in there and give you a feel of how it's working. We'll go ahead and start out by pressing N for a new game and put in our name or my name, and we'll go to reports first, and then we'll view the list of animals in the storehouse. Select that option, and here we go. Here it's got basically just a list of the animals: horses, dogs, hens, animals, and 400 animals total. Okay, and we can exit out of that, and it'll, as you see, the annual report comes back, and our year one here, nobody starved, 5 people moved in, and so when you quit, go back to managing the crops and pay tithes and 20%, and it saves how much we're paying for tithes in there as well. So this is just a small part of the game that we created this semester. So here is our game as far as we've gone, and I'm going to go ahead and run you through what options are in there and give you a feel of how it's working. We'll go ahead and start out by pressing N for a new game and put in our name or my name, and we'll go to reports first, and then we'll view the list of animals in the storehouse. Select that option, and here we go. Here it's got basically just a list of the animals: horses, dogs, hens, animals, and 400 animals total. Okay, and we can exit out of that, and it'll, as you see, the annual report comes back, and our year one here, nobody starved, 5 people moved in, and so when you quit, go back to managing the crops, and pay tithes, and 20%, and it saves how much we're paying for tithes in there as well. So this is just a small part of the game that we created this semester.